Good morning to one and all. My name is Sherry. I am from VVIT EC branch. Today I am going to explain the topic stationary and ergodic process analysis of random process in a psychosis system. Let us start our topic. Let's see what is wide sense stationary process. Wide sense stationary process is also referred as weak sense stationary or second order stationary process. Represent a fundamental classification in analysis of random process. This process exhibits statistical properties that remains invariant under the transients through a limited sensor compared to the strict stationary. A random process x of t is classified as the wide sense stationary when it is classified two essential conditions that are characters with static behaviors. Condition 1 is time variant mean. If x of t is equal to x bar or constant, the expected value of mean under process of across all the instances. This condition ensures that the average behavior of process does not drift or changes systematically over time. This means value remains the same regardless when we observe the process. And condition 2 is autocorrelation depends only on the time lag. The autocorrelation function which measures the correlation between the process at different times depend only on the time difference tau between observations do not absolute time values, that is E of x of t into E of x of t plus tau is equal to autocorrelation R excess of tau. These properties indicate that the correlation structure of the process is uh, identical at the time points only on the relative times separation matters. The function autocorrelation is independent of absolute time, taking function solely of the long t tau. And we can see what is joint wide sense stationary process. We analyze multiple random processes simultaneously. The concept of wide joint sense stationary extends the stationary. The two random processes f of t and y of t are said to be wide sense stationary if they satisfy specific conditions regarding both their individual properties and their mutual relationships. Individual stationary requirements are given below. Each process must independently satisfy the wide sense stationary conditions. Process x of t is wide sense stationary with the constant mean and the autocorrelation Rxs of tau. Process y of t is wide sense stationary with the constant mean y and the autocorrelation R of y of tau. Joint stationary conditions are the cross correlation function between the two processes must depend only on time lag tau, that is Rxy of t1 t2 is equal to E of x1 x of t1 into y of t2 is equal to R of xy of t2 minus t1 is equal to Rxy of tau, means autocorrelation of x and tau. In this we can see that mean is constant, that is both E of x of t and E of x of y remains constant over the time, and individual autocorrelations. R of xs of tau and y R of yy of tau depends only on time lambda. And we can see what is ergodic theorem and what is ergodic process. The ergodic theorem established one of the most powerful results in ergodic and random processes, building the gap between the time domain measurements and statistical ensemble properties. The theorem has profound practical implements for signal analysis and experimental measurements. The ergodic theorem statement tells us that for a ergodic random process, the time average computed from a single sample function are equal to the corresponding ensemble average. Statistical exponential, that is computed across all possible realizations of the process, that is time average is equal to ensemble average. And the equivalence holds with probability 1, meaning that a single sufficient long observation of the process contains all the statistical information needed to characterize the entire ensemble. Definition of ergodic process. A random process that satisfies the ergodic rhythm is called a ergodic process. Such a process that remarkable property that any single sample path realization is representative on entire statistical ensemble. Key factors are for ergodic process the following equivalence holds the mean and autocorrelation function. That is the average of mean equal to the reassemble mean that given the limits t tends to infinity, that is 1 by 2 integral 0 to t x of t dt is equal to e of x of t is equal to constant, that is x bar. And we can see the specific type of ergosity. And ergosity is not all that nothing properties. A process can be ergodic with respect to some statistical properties while not being ergodic with respect to others. Understanding the specific type of ergodic is trivial for parametric applications, whereas different statistical measurements can be interrupted. Mean ergodic process. The random process need to be mean ergodic or mean in ergodic in mean if the time average on the sample function equals to the statistical mean on the process. This is most commonly encrypted from the ergodic in practice. Mathematically, a process x of t is mean ergodic. If e of x of t is equal to x bar, that is limit tau tends to infinity 1 by t integral 0 to t x of t dt is equal to x bar. The equality must should be with the property 1, probability 1. The notation E of x of t represents the ensemble average and x represents the time. X of t represents the time. Sufficient conditions for mean ergodic. The process must be wide and stationary. The variant of time average means approaches zero as the averaging integral approaches infinity. The condition ensures that the average converges to constant value. The ensemble mean influence the randomly. And we can see joint ergodic process. When we are working with two or more number of random process, we need to consider that they joint ergodic properties. Two processes that x of t and y of t are said to be joint ergodic. If the individual ergosity, each process must be ergodic individually. This means the both the input the both x of t and y of t separate widely the ergodic property of their representative mean and autocorrelation function. And we can see the cross correlation ergosity. The mean average of cross correlation function must be equal to the ensemble cross correlation functions. That is r of xy of t is equal to limit t tends to infinity 1 by t integral 0 to t x of t of y of t plus tau dt is equal to e of x of t into y of x of t dt. And here are the some of the key summary of key concepts. And we can see what is the description and the key equations of Whiteson stationary, Shipson stationary, ergodic theorem, mean ergodic, joint Whiteson stationary. And we can see also the conditions or key equations for this. And we can see the relationship between stationary and ergosity. Understanding the relationship between stationarity and ergosity is crucial for proper applications. These concepts in signaling processing and statistical analysis while closely related. Stationary is necessary but not sufficient. For a process of ergodic, it must be stationary. However, not all processes are ergodic. Ergodicity implies additional contribution behind stationary. And the stationary ensures that the stationary property does not change over time. Ergosity ensures that a single realization contains all stationary information. A process can be stationary while all having sample functions like different significantly from one other, preventing any single sample from representing the symbol. Here you can see the applications and practical significances of signal processing and communication in the mechanical and structural engineering and financial time and series analysis, environment and climatic science. Here you can also see the testing and verification. Before applying stationary and ergodynamic conditions, it is essential to verify them. And you can also use the stationary test and ergonomity verifications. And this concept of stationary and ergonomity are not mainly theoretical concepts, they form the foundation for numerous practical applications across engineering, physics, and applied mathematics. Under when and how to apply this concept is essential for effective signal analysis and system design. And you can see the conclusion and takeaway. Understanding stationary and ergodic process. You can see the stationary defined invariant properties, ergodic enable particle measurement, and joint properties extend to multiple. You can also see the particle blindness for application. And thank you for